Hello. Welcome everyone to the SIG-Multicluster intro and deep dive. I'm Jeremy Olmsted-Thompson, one of the co-chairs of SIG-MC, and I work on GK at Google.
And I'm Stephen Kitt, the other co-chair, and I work on multi-cluster at Red Hat.
And I'm Lorenz, and from Microsoft working on multi-cluster.
And my name is Laura Lorenz. I work at Google on GKE.
All right. So what are we going to talk about? We're going to kind of give a high-level overview of what this SIG's about and how we approach the problems. We're going to go into some of the cool things that we're working on, and then and some new things that have recently developed, and we're very excited. And then we'll get to how you can contribute, and the most important part here is hearing from you. So what are we about? Clusters, right? Multi-cluster is everywhere these days, and I think we've shown this before, we've talked about this before, and I feel like, you know, this has been increasingly true at every KubeCon for years now, and this year more than ever. You know, we're seeing lots of the problems we've talked about in the past, and that I'm sure a lot of you are familiar with, fault tolerance and data locality and policy, and these things, you know, drive you to need more than one cluster for your workloads. But more than ever, especially with, you know, the AI boom we're seeing right now and this increasing utilization of this scarce capacity, we're seeing the need to do things like capacity chasing and, you know, running workloads that are just kind of finding the hardware wherever they can. And multi-cluster is, you know, the best way to do that in Kubernetes. Now, some of the problems here are that Kubernetes was built with the cluster as basically the boundary of the universe, right? All of the concepts in Kubernetes don't really have any self-identification built in, right? And so we've been slowly kind of whittling away at that and making some progress at things like multi-cluster services and the About API. We'll talk about these soon, where we've kind of introduced ways to you know, break down some of those barriers, but there's a long way to go, although I feel like less than there has been in the past, and hopefully someday very soon we'll say we did it, but you know, I think it'll be some time. And we really need your input. So there's been, you know, everybody here, please come if you have questions or use cases. We'll talk at the end how you can participate, but we'd love to hear your stories. And thank you to those who have recently come and kind of talked about how they do things. So what is our approach? It's a very diverse ecosystem. We've got clouds, we've got multiple clouds. They're, you know, they have their own quirks. We've got on-prem. So we want to work around, you know, recognizing the environmental constraints and how, you know, different topologies are, different cluster deployment topologies are, you know, can do different things, and focus on APIs that work everywhere. We want to avoid solving optional problems. So, you know, focus on like the core problem, and that's where, you know, we started with multi-cluster services and have been expanding out, just focusing on, you know, simple use cases that solve concrete problems that everybody has, and making sure that, you know, we are consistent and compose well with existing APIs, so that, you know, we're producing a series of building blocks that you can use in whatever way you see fit. A core building block, and this is conceptual, is the ClusterSet. And what this is a real pattern of use that we see in the field. It's a set of clusters governed by a single authority. It could be an organization, could be a company, could be a platform team, with a high degree of trust within that set. So these are clusters where you expect to deploy similar applications or the same applications across the set. And they all revolve around the thing that brings them together is this concept of namespace sameness. And that is that, you know, a namespace with the same name in any cluster in this cluster set is used for the same purpose. That means permissions, the same kind of workloads. And a namespace doesn't have to exist in every cluster, so that, you know, you can segment your fleet. But when a namespace exists, it means the same thing. So, you know, we discourage things like calling every dev namespace dev, and then you end up with a bunch of conflicts. So better names that are identifiable in this, you know, multi-cluster case, moving towards the world of cattle, not pets.
So on our way to move to, let's see, so to cattle instead of pets, there are a few projects that we are working on. And the first one is about API, right? What it is about. As Jeremy alluded to first, is in the beginning, Kubernetes actually is the whole boundary is its own cluster, so it is the universe. And like, do you know what's the name of our own universe? We don't know. It's the universe, so you don't need to have a name. But then somehow we figured that it's multiverse. Now you need a name. So About API is there to give a name for that universe. So that's where it comes from, and I think we had multiple votes to decide what exactly that idea is called. So we get that settled. So finally, our universe has a name, and we go way beyond that, right? Just the name itself is good, better than nothing, but we still need to know a lot more about this universe. So we are in the process of adding more properties into this API to have more universal community-driven or consensus properties there. So we can actually describe that universe better other than just a name. So with that, it is... actually, I kind of just go through that. It's what give it more concurrent, give it more well-known properties. And with that, one of the reasons that we need to describe a certain cluster is orchestration, right? As, again, Jeremy alluded to that. Nowadays, many times you want to know where you put your AI jobs, whatever jobs you have or applications there, because there are certain scarcity of resources or price and you want to go find the least expensive places. So how do you describe that? That's where this property comes into help, right? If you have certain properties you can associate with that cluster, then you can make those decisions. Otherwise, you only have names. You have a whole bunch of kettles, they all have names, but you really don't know who is who, or who are good at what. So, historically we have made a few attempts, at least from the SIG side, and one of the probably more famous one is the KubeFed. We say that probably it's not the most success story in the SIG's history, but that demand still exists clearly. And again, from this KubeCon, I don't know how many, I lost count of number of multi-cluster talks. My hands definitely is not enough to count. It's like every day you see 10 of them or something like that. So it's clearly the demand is there, the use case is there, the community is looking for some common solutions. They don't have to reinvent the wheel. So from a SIG standpoint view, the first thing that we take a stab at that is called a cluster profile API. That's kind of the youngest API among these existing APIs. So that proposal comes from a lot of open source project that has real world usage, and we come together, and with multiple discussions, we get to kind of beginning of that cluster. It's still a journey that we haven't finished yet. So two things that we're really trying to get to that is, so what is the cluster profile, right? The cluster profile is you have About API that describes itself, but when you get to multiverse, you have this kind of kettle ranger. You actually have to figure out which kettle works best for which metal, whatever you call it, right? So at that point, you want to have a representation of each cluster. So cluster profile is for that purpose. It's a read-only cluster. Read-only API means it's reflective of the certain properties, which could be about API properties, and then you can do scheduling or orchestration there. So there are two pieces that we are really working on now. One is the credential part. So because just have a object representing a cluster doesn't give you automatic access to that cluster. You still don't actually have a way to do that. So and obviously store the secret someplace isn't probably will not fly with any of your security compliance officers. So we need to find some way that is better than that. So we are working on that. The second one is again the properties. We have proposals here. We would love some more inputs from the community. Give us feedbacks. It's the work in progress. Let's see what's next. Yeah, so this is kind of the cluster profile properties diagram. I don't know if we can see clearly. Basically, you can see the yellow ones are the real clusters, and the blue ones are the cluster profile that is just representing those clusters. And then you have a cluster manager that basically sitting up top there and say, okay, I know which one, every cluster, what they are doing. And then the best part is with that unified API, you can actually have popular multi-cluster enabled third-party like Argo CD, Flux, Q, multi-Q to actually integrate with any of those cluster managers that speak this language. It's kind of like now you don't have to talk to them individually. You have one common language that you can talk to. So that's kind of the beauty of that. We are still working towards that goal, especially about that secrets. When we have this credential part sorted out, this will work very well. And lastly, the cluster profile API itself doesn't live in the vacuum. As I kind of alluded to before, that you have the about API that we get the properties from, and you also have this work API, another API we sit in the SIG that about how do you actually assign jobs to each cluster, right? You know this job, you understand it, now you wanted this cluster to actually do some work for you. So that's where the work comes into being. And even with that, after you have the work there, you still want them to talk to each other. And here, that Laura is going to.
All right, I'm going to talk about a couple more projects that occur in SIG-Multicluster. One of them, which is one of the older ones at this point, so if you have been to a SIG-MC talk or followed in the past, you've probably heard about this, is the Multicluster Services API, or the MCS API. This is a standard for how a service object, just like you're used to in a single cluster environment, can be basically flagged to be exposed across a cluster set, so that it could be consumed by workloads that are in a totally different cluster from it. There's some links here about the Multicluster Services API. Since we last gave a maintainer update in North America, Cilium has come a lot further on its implementation of the MCS API, and there's also a ton of other implementations of this API that you can take a look at. There are some updates ongoing regarding as more implementations use this API, then we get, of course, more feedback about how to improve that or how we can represent the standard better. So there's a V1 Alpha 2 still in progress. And another really important aspect of this, the Multicluster Services API is about service discovery across clusters, so you can also think of that as like an east-west direction. But the Gateway API, as many of you may also know, is about that north-south traffic from a client outside of the cluster to get to endpoints that are inside the cluster. And there's an integration point there if people from outside the cluster would like to contact any of the endpoints that might be representative of whatever that service is across a set of many clusters. So that connection point between the MCS API and SIG-MC and the Gateway API in SIG Network is something that we work very closely with them on. And there's another link there to a GEP, Gateway Enhancement Proposal, that talks a little bit more in detail about how those leverage each other. Yeah, and this is kind of like a little cute version of the MCS plus Gateway. One other project that is super, super new that just recently was proposed to the SIG for adoption as a project under the umbrella of SIG-Multicluster is Multicluster Runtime. This is an extension of the existing controller runtime framework for multi-cluster use cases, and it's intended to be a drop-in solution, and is something that we also see a very close connection with the work that Ryan was talking about regarding the cluster profile and the idea of exposing these standards of how that list or inventory of like what all your clusters in the multiverse that you live in, that is a really good integration point with what the folks who are working on multi-cluster runtime were already working on. We also like this since, as we mentioned in the approach slide, as SIG-Multicluster, we're really trying to integrate well with the existing Kubernetes APIs as you're used to them in a single cluster environment. I didn't talk about this too much in detail, but important part of the multi-cluster services API was to make it feel like you were just using a service, but like it just happens to be in multiple clusters. And the multi-cluster runtime project is also trying to take this existing framework controller runtime that everybody is used to and make that something that can be used across a multi-cluster cluster set. So I'm going to hand it over to our co-chairs again to talk about what's next.
Thank you, Laura. So coming up next, in no particular order, and this isn't exhaustive either, so cluster profile API, we need to work on integrations of that with the actual ecosystem. As Jeremy said at the start, we focus on providing actual APIs that have meaning across a variety of implementations, but we're also interested in keeping track of the implementations themselves. For example, Argo CD, multi-queue. We're also very, very interested in coming up with canonical patterns. If you look at the people up here, we all work for infrastructure providers in one way or another. We're not actually building solutions with these multi-cluster APIs, so we might be getting things wrong. So that's why we're really keen on getting feedback, and I'll come back to that, from users in the SIG, and we with the goal ultimately of coming up with patterns, not just the APIs themselves, but how you can use them to build applications that work across multiple clusters, things to watch out for, things that work well. And then, so I'll skip the next one because Jeremy wants to talk about that, but also just figuring out what else we need. Because as Jeremy said too, multi-cluster has been growing in at least visibility, events such as this one, and we've also switched, it seems to me, from having multi-cluster meaning just provisioning multiple clusters and being able to manage them in a comfortable way to actually building applications that are designed to use multiple clusters, and so connecting them, having information about all of them. And there are probably pieces that are missing, or pieces that every single implementation does in similar ways, and so should perhaps become libraries. But yeah, we know that there's a bunch of stuff to add. And Jeremy, I'll let you talk about leader election.
Yeah, this one's kind of been a pet vision of mine for quite some time. But I think especially with the recent adoption of the multi-cluster runtime project, and as we start exploring more in that vein, the need for multi-cluster coordination is more important than ever, right? Now that we actually potentially have a path to running clusters or running controllers across multiple clusters and in multiple clusters, we need a way for them to coordinate. So I think this is one of those really interesting areas that's more and more important over time, and also a great starter project for anyone who wants to come in and start kind of ideating with us on what that could look like.
Right, and there are a few other things too that spring to mind that aren't on the slide, but in general, anything that you can do inside a cluster where we need to think about how it could be done across multiple clusters, that's also interesting to us. And so, for example, KEP 4444, I think, is now available, and so that allows you to specify when you're talking to services, whether you want local ones or remote ones. That's something that SIG Network did, but that's probably that we should be thinking about extending in SIG-Multicluster. There's also the question of network policy that comes up a lot that we'll have to tackle someday. And with all this work to be done, we really need more, not necessarily people to work on it, but more input. So we're interested in finding out what you're all doing with multi-cluster in general, whether it's with multi-cluster APIs that have been developed in the SIG or not. If you find that what we're doing is missing the mark, that's very interesting to us. And things that you're building, things that you would like others to build for you. And so we're always interested in seeing your designs, seeing how you work with all this stuff. So demos are always welcome. What problems are you trying to solve? And what unique needs do you have that we haven't taken into consideration? Because you might think that they're unique to you, and it turns out that very often they're not. And so if you're interested in helping, we could use help with the test suite. So if you, well, our APIs have got test suites to go with them because they are APIs that are designed to be implemented by multiple implementations. We provide something like conformance suites that allow implementations to say, okay, we meet the requirements. Our website is lacking in detail and could use some work. Also recently, so we mentioned this, multi-cluster runtime is now hosted in the SIG, and it's an experiment, so we're looking for people to try that out and see if it works. And so how can you do all this? Well, come to the SIG. We have a website that you can find there, so the slides aren't up on Sked yet, but we'll upload them. You'll be able to find them there. There's a Slack channel where you can come and chat with us. There's a mailing list as well that you can see here, and if you sign up for the mailing list, you'll automatically get a calendar invitation for our meetings, which up until now were bi-weekly, but we're changing them to be weekly starting next Tuesday. You can see the times there. And that's it for the presentation. We've got a few minutes for questions. There's a mic in the middle there.
Hi, so it's not as much a question, but I think yesterday at ArgoCon there was also, I think it was for MCO, the multi-cluster operator, there was already some integrations-ish demonstrated. I think what they intend to do is make use of the About API, not use the Work API, and then still do their own credentials as a sort of midway while everyone is working on it. Is this something you guys feel is the better way to do it? Because on one hand, you end up with people with kind of in-between configurations. On the other hand, it does move everyone forward. I mean, what is your perspective on that?
Yeah, I can start. Yeah, so I think, well, I guess Quarantine could come up here too now. Yeah, but so MCO is intended to integrate with the SIG-MC standards. And I know there's like kind of where it is now, and then there's like where it's like going forward too. So we're in a point in time right now, and integration with the About API and the Cluster Profile API are the priority for MCO specifically. I think SIG-MC, or maybe even to back up more, Kubernetes has always been really interesting because sometimes it works as an organization that ships software, and sometimes it works as an organization that ships standards. And SIG-Multicluster, because we recognize that there's like lots of different environments that people are going across cloud or in cloud or on-prem, or like the reasons and the variety of how they're deploying things multi-cluster is still like, you know, there's some level of like standardization that we just like can't, or like there's a high ceiling, there's a high skill ceiling, you know? So, so it's always been important to us to like find that space between when are we shipping like the solution and when are we shipping the API that like people can coalesce around. So I think for MCO, integrating more with the standards as we've set them is the plan, and then we expect and desire there to be many different implementations of these APIs. That's definitely the goal. And then I think one last bit is that when in that process that the different implementations are having a difficulty like staying on standard, or whether because they have a legitimate like edge case or reason to do so, or because it's too hard for them to meet the standard, that's a place where I do think it is the jurisdiction of SIG-MC to provide the libraries, figure out where that, if that line of like, when are we shipping software and when are we shipping, like kind of like nudge that to like wherever it is that makes that easier. In fact, Cluster Profile is a great example of that, because there's a long time where SIG-MC was kind of avoiding an API about that because there wasn't really a clear consensus on what that would mean, and we did get more people in the room and more people at the table to talk about that, and then now we feel more confident that that's something that people can reasonably adopt and that we have the bandwidth to help them adopt if it's missing something.
That just sparks more questions, but
Okay.
there's no queue, so.
Go for it.
One is in Istio, you have service imports and service exports. I think that is exactly the same API as we're going to see in the multi-cluster, or not, maybe not exactly, but it's very similar to when you want to choose to export or import a service from another cluster. Is that something that is scheduled to be part of multi-cluster soon, or is that something that we're pushing out? Or just so it's essentially the same question for Argo, but then for Istio, because they're doing their own thing in one way. In the other hand, they are also doing the gateway API, so that is more towards a common standard. And I suppose they're going to do the same thing with service imports and exports, perhaps similar to what Cilium needs, to what Linkerd needs. They are all common needs.
Yeah, so the service import export API, that actually is the MCS API. That is the multi-cluster API, and Istio is an implementation. And MCS is an example of something where we defined a standard and no implementation. And there's several implementations. We on this stage and a bunch of folks in this room have built their own and collaborated on various implementations. And yeah, that is, Istio is one. So that's a great example of, I think, the standard actually working. So that you can do it on this platform, you can do it on that platform, you can use Istio, and it's the common pattern.
All right, that makes a lot of sense, because it was working so well that it was just happily using it and ignored the documentation. So, yeah.
Good job, Istio team.
And if you're interested in seeing the APIs actually in use, there was a very nice presentation yesterday by Ryan and August. You can watch the video when it's available, if you didn't see it yesterday, about SIG-Multicluster APIs in use in OCM and KubeFleet.
And also cluster ADM, right?
No.
Or was it not a talk?
But yeah, we haven't watched all the multi-cluster talks that have taken place at this KubeCon.
Yeah, we have those. GKE has one. There's really quite a few now. It's great to see the proliferation.
You were mentioning the link between MCS and gateway, and how gateway is normally north-south and MCS is east-west. But with Gamma, gateway's approach to that is to use service mesh for east-west. And so I'm wondering how that interacts with MCS, which is doing it obviously without a requirement for a service mesh. And yeah, how does that work?
So that actually kind of builds on the previous question. I think the MCS API is really just the API. So whether you're using a service mesh or not, using a gateway, you can target a service that is in a single cluster. That's kind of the traditional gateway approach. Or you can target a multi-cluster service. And whether or not you're using a mesh, you're basically saying, I don't care where the endpoints are, right? It can be across clusters. It can be in that cluster. It could move to a different cluster. But it's a way of kind of creating that abstraction. So a service consumer doesn't really need to worry about where the producer decides to put their workload.
Right, so whether there's a mesh or not is just an implementation detail.
Exactly.
Okay, cool. Okay. Thanks.
Thank you for your presentation. So I've seen that you actually have some standards for the east-west traffic. So how the services actually talk to each other in different clusters. But are there any standardization on north-south traffic as well? So when clients wants to reach to different clusters, there are projects like CaseGB, I think, CNCF projects. But are there any global service load balancer type of standardization that you are thinking of as a replacement for ingress in multi-cluster?
So that's precisely what Gateway is trying to accomplish. So Gateway would be the Gateway API. There's many ways to use the Gateway API, and many it's effectively like the next generation ingress controls, right? So you can build your global load balancer out of the Gateway API and target that multi-cluster service and kind of build that abstraction so that you don't need to you care, or you can control how clients connect to your service.
Okay, but there's still like, are they going to like operate on the proxy level per cluster, or is this something that integrates with the upstream DNS servers?
Upstream integration. So yeah, the multi-cluster service, like the bare bone. Well, it actually depends on the implementation. But for example, having worked on GKE, I can talk about that. Like it's a bare bones, like kube proxy or whatever data plane based solution. But when that's where you can plug in a service mesh and get more capabilities. Using Gateway, you kind of move things up a layer. So the idea is that the API describes what you want to achieve, which is make my service available. But the implementation can vary depending on how you're consuming it and all the configuration and whether or not you're using Gateway and how you're using Gateway. And so, it's a lot of control and flexibility, but in a common pattern so you can swap pieces in and out.
Okay, thank you.
Thank you, everyone.